Hello, and welcome to Fun with Chemistry with Jack.
And Sam.
Today we are going to be making some sugary popsicles for you, and we will be using the concepts of the heating curve of water
And heat transfer.
Now, the first step of our cooking video is we must fill these cups with water so that they can be frozen. Second, we are going to put some sugar in the water to give our popsicles some tasty flavor. And then we will stir to make sure that the sugar molecules are equally diffused throughout the water solution. Next, we will drop popsicle sticks into the water so that when the water freezes, we will be able to get the popsicles out of the cups.
Yay.
Oh, I didn't see you there. While we are about to put these popsicle solutions in the freezer, it is important that we go over some key chemistry concepts that are going to allow these water solutions to freeze into the tasty popsicles that we know and love. Popsicles are quite interesting as we can see dynamics of the heating curve of water, the freezing point of water, and the chemistry that goes along with these two concepts. While my partner will be discussing the heat transfer in these popsicles and that goes along with the freezer, I will be telling you all about the freezing point of water and how it relates to these popsicles. The freezing point of water is the temperature at which a liquid of a certain makeup, such as water or sugar water, solidifies with it being under a constant pressure. If the pressure changes, the freezing point and boiling point will change as well. Now, it is important to understand that water freezes at 0 degrees Celsius when attractive forces are made between condensing water molecules. This thus causing what was a liquid to become solid inside of a cold space. In relation to popsicles, once the sugar/water solution is put into a freezer with an appropriate temperature of -2 degrees Celsius, approximate temperature of -2 degrees Celsius, the water will freeze into popsicles. However, an interesting fact about sugar is that its chemical composition lowers the freezing point of water, so it will take an extra cold freezer for the water to successfully freeze, as well as the popsicles being required to be in the freezer for a longer period of time than they would if it was just water. This is because it lowers the heat of fusion of pure water being 273.15 joules per gram to something significantly higher, therefore requiring more energy to be taken away from the popsicle. Now, some interesting facts about popsicles. Anyone? Anyone? No, okay. Does anyone know who created the popsicle? The popsicle was created by Frank Epperson at the age of 11 when he accidentally put his soda in the freezer instead of the fridge. When he came back later, he pulled out his soda and tried to drink it as it's melted. And therefore, the popsicle was born. Now, let's throw these in and see see the key concepts of the heating curve of water, the heat of fusion for water and sugar water, and see our tasty popsicles in action.
Those are in the freezer. Let me discuss the heat transfer going on inside. Convection is the major heat transfer going on inside there. We know this because the cool air is circulating around the popsicles, absorbing the heat energy that they get off. This will eventually cool the popsicles down to its freezing point. Although, convection is not the only thing going on. Conduction is also occurring because we place the popsicles on a cool surface. This will also cool the popsicles down. Also, if you look at it on a molecular level, you will see that the air molecules are taking heat energy away from the liquid molecules.
Thanks for tuning in. Until next time, I'm Jack Longenecker, and this is Fun with Popsicles.